Good. Okay. All right. So here, okay, if you remember, this is something we did last time. I think I might have left off with the slide after this, but I just briefly want to review how to find the area between two z-scores. Again, what can happen is with a normal distribution, you may want to find the percentage of data values less than something, you know, and again, that amounts to getting the z-score and getting the area under the curve to the left of that z-score. Under the curve, I mean under the standard normal distribution, right? Now, if you want the area between two numbers, you get their z-scores. That is, if you want the percentage of data values with a norm that has a normal distribution, okay? The percentage of data values between two numbers, kind of like with the empirical rule, what you do is you get the corresponding z-scores and get the area between, the z-scores under the graph of the standard normal distribution. In other words, you would get this area. We saw last time that if you want the area greater than the z-score, you do 1 minus the area to less than the z-score. So here's another example. So let's suppose this is something I got from the textbook. I mean, so the annual rainfall, let's say, in a certain region, it's approximately normally distributed. And let's say it has a mean of 33.5 inches and a standard deviation 5.6 inches. So the annual rainfall in a certain region, okay, it's normally distributed with this mean and standard deviation. Let's find the percentage of data values less than 30 inches. Okay, so that's what we want to do here. We're also going to get the percentage of data values less than 40 inches and the percentage of data values between 30 and 40 inches. All right. Okay, so again, what we can do is get the z-score. If you remember, we had a table. Actually, let me get that table open. I forgot to do that. I'm just going to get the table quickly. Let me just get that. Should be, if you go back to the table again, the table is in the textbook. It's in chapter 12. See, it's opening up here. No, that's not it. Here we go. Yep, there it is. Okay, good, got it. Okay, so again, we want the percentage of data values here less than 30 inches. I mean, I will show you how to find that using Desmos, but for now, let's use the z-scores. So for the z-scores, okay, well, we know the mean is 33.5 inches. The standard deviation is 5.6 inches, right? So to get the z-score, right, for the data value, we subtract the mean and divide the difference by the standard deviation, okay? That's just what we do. Subtract the mean and divide by the standard deviation. Okay. So from here, we're going to get negative 3.5 over 5.6, which is about negative 0.625. So that's the z-score we want. Let me share the data. Let me share the table from the textbook. Gotta stop sharing this time. There it is. All right, so here, let me zoom in a bit. You could probably, I hope you can see, we had negative 0.625, if I remember correctly. Yes, that's right. But if you notice, though, that's not on the table. So what do? We have to round. Namely, what we do is we look for negative 0.6, which it looks like is over here. Okay. And from here, what do we get? We get 0.2743. So the area to the left of this z-score is 0.2743, which means, let me just get back to the, here we go. Here it is, which means that the percentage of data values here for the annual rainfall in a certain region, okay, it's about 27.43%. Okay, so the percentage of data values is about less than 30 inches is about 27.43%. You know, in other words, the annual rainfall, about 27.43% of the how do I say this? The years, the rainfall is less than 30 inches. Okay, I think that's how you interpret it. Okay, but again, the percentage of data values, that's enough also as well. Okay. About, if you want, I guess you could say also about 27.43% of the annual rainfall in that region is less than 30 inches. Maybe that's a better way of saying it. All right. For less than 40 inches, it's really the same idea. The only difference now, instead of 30, we're going to use 40. So we have to get the z-score for 40. Okay. So here we have 40 minus 33.5 over 5.6. Again, we subtract the mean, divide by the standard deviation, and we get 6.5 over 5.6, okay? And we get 1.1607. Now, I'm not going to go to the table again, but if you did look in the table, because I didn't want to keep switching between screens, but if you did look at the table, okay, you would see that this is not in the table. So again, you would have to round to one decimal place. I mean, I'm sure there's tables out there that have the area for numbers like this, just not the table that we have. So we round it to one decimal place, which is 1.2, because that is in the table, that's the closest, and we get 0.8849. So that's what we get. So this tells us that about 88.49% of the annual rainfall in a certain region is less than 40 inches. That's not, how did I miss that? That's not years. That should be inches. Okay, there we go. Okay, that's fine. There we go. Okay. I don't know how I missed that. I'm sorry about that. There we go. Okay. Good. Okay. So for less than 40 inches, the percentage is about 88.49%. Now, what about the area between the two? Well, you just subtract. Now, I think this came up last time. What did I say years over there? Inches. Sorry about that. Okay. So now here also, you want the area between the two z-scores. In other words, you want the area between 30 and 40 inches, right? The percentage of years that will have an annual rainfall between the two. That's probably that's the better way to interpret it. You basically subtract the areas. You know, the bigger z-score minus the area with the bigger z-score, excuse me, the bigger area minus the smaller area. And you'll get 0.6106. And so that tells us the percentage of data values, okay, between 30 inches and 40 inches, it's about 61.06%. Okay. Or if you want, again, you can interpret it this way, the percentage of years, because it's annual rainfall, the percentage of years which will have an annual rainfall between 30 and 40 inches, it's about 61.06%. Okay. All right. Are there any questions on this one? Okay. I know the interpretation I might have messed up, but the calculations are correct. Okay. All right. And these are just the graphs also helping to illustrate what we just did. You know, we have the different z-scores. This is for the 30 inches, we get the z-score. For the 40 inches, we get the z-score as well. And we get the corresponding areas. And for the third part, between the two, graphically, this is what we're looking for. That's what we're looking for. Okay. All right. Now, as I said before, you can use Desmos to get that area. I mean, the table and the z-scores people do use, but you can also use Desmos as well, you know, as another way. Basically, what you do is, I'll show you shortly, there's also screenshots here in the notes. You essentially graph the normal distribution curve before I told you do not click that find CDF, cumulative probability function. But now you are going to click it. And when you click it, you would actually get these, see if I can get here, you'll get these min and these maxes here. You know, so in other words, you go into Desmos, this is where you are. Then you type in or put in normal dist. Here I have 0, 1, but really you could put in any one you want. It'll still be able to calculate. But you'll click, that means you'll check finds cumulative probability, CDF. And you'll actually get the min and max here. It turns out area under the graph is probability, but that's a totally different story. Now, if you leave those blank, you know, if you go to Desmos, if you leave them blank, that's basically telling Desmos there's no bounds, no finite bounds. And I don't know if you can see it, but it looks like there's like a negative figure 8 on its side. Same thing over here with max, except it's not negative. This is actually negative. Some people call it minus infinity. Negative infinity. Some people call it minus infinity. This is infinity. It's just notation for keep on going and never stop. Where negative infinity means you keep going in the negative direction. You keep getting more negative and not stopping. For infinity here, it keeps on increasing, you know, getting more positive and not stopping. You know, if you leave those blank, that's what's going to happen. Otherwise, you can put numbers in and it will calculate it. For instance, here, okay, so again, with Desmos, when you open it, you know, this is the graphing calculator. I'm logged in. If you put normal dist here, again, I mean, if you left these blank, it would do the standard normal distribution, but you could do any normal distribution. You may not be able to see the graph, but you can still do it. You click, you check this, find cumulative probability. But for instance, if you went from the area to the left of 2, so it keeps on going to the left, this is the area you'll get, and it gives you the actual number here. You don't have to, okay, gives you the actual number.